Hi everybody, this is Mike Yeoman again, and this is a tutorial video to help you with your final. So again, I'm using your airbag lab that you were working on before break in order to help prepare you for your final. I don't want to give you all of the information, but I would like to model that for you so that you can kind of see what's going on. So I'm going to use the same equation that we used for the airbag lab, which consisted of acetic acid, excuse me, acetic acid, and which is essentially vinegar, uh, baking soda, which is sodium bicarbonate, and we had determined that it produces three products. And the first one for the lab, for the airbag lab, the first one that was produced or that we talked about is the only one that we cared about, which was carbon dioxide, because we wanted to fill up your airbag with a gas. So that was the only one that we really cared about. But we do need to keep in mind that there were two other uh, products, water and sodium acetate. Okay, so now we have an unbalanced equation, but to check to see if it is balanced, we could go back and count up how many atoms there are. So I have, I'm just going to start with hydrogen since that's the first uh, atom on this side, on the reactant side. So I have 1 plus 3 is 4, plus 1 more is 5 hydrogens on the left side, on the reactant side. And then on the product side, I have 2 plus 3, that's also 5, so my hydrogens are okay. If I take a look at my carbons, I have 1, 2, 3 carbons on the reactant side. I have 1, 2, 3 carbons on the product side, so that looks good. And then all I'm left with is oxygen, so that's 1, 2, plus 3 for a total of 5 on the reactant side. And then I have 2, 3, 4, 5 oxygens on the product side. So it looks like everything's good. So I have a 1 to 1 to 1 to 1 to 1 ratio, which makes our numbers very easy to use once we start plugging that into our dimensional analysis and doing some stoichiometry. So for the airbag lab, what I asked you to do was convert from these two products. Actually, we figured out how much CO2 we would need in order to fill your airbag, and then we tried to determine how much baking soda and how much vinegar, how much acetic acid, and how much sodium bicarbonate we would need in order to make a certain amount of CO2. So your final is set up in a very similar way. What it is I've told you that I want you to produce a certain amount of product, but you have to make it from these two reactants. And so I'm going to set this up, but instead of using each one of your finals, because they're all different, and I don't really want to do it for you, I just wanted to model this for you, I'm going to continue to use this same equation. So I'm going to change it a little bit more. So one of the things that I'm going to have to figure out is how much, okay, so starting with my question mark, how much, let's just go with acetic acid, and that's measured in liters or milliliters. So I'll just go ahead and put milliliters here of acetic acid, what I need in order to make a certain amount of, well, I'm going to go with the only solid that is on this side, which is sodium acetate, the only solid product that is produced. And so I'm just going to make up a number. So I'm going to say 1.7 grams of sodium acetate. Okay, so we have our information that's provided to us, and we also know what we're trying to find. So now we just need to find a pathway. So we are starting with grams. Okay, and so if you use that handy dandy sheet that I gave you in your packet, it has that visual, that graphic organizer that shows you how to convert between different groups. And so we're starting with grams, and so the only thing that we can convert into, or at least is available on that particular graphic organizer, is into moles. Okay, so we're in grams of one thing. So in this case, I'm just going to call NaCH3, I'm going to refer to that as A, and I'm going to refer to acetic acid as B, just to make it a little bit easier here. So grams of A can be converted into moles of A. All right, so I want to get into something else. I don't want to be in sodium acetate anymore. I want to be in acetic acid. So what I can do is I can convert from moles of A into moles of B. And from there, we have one more step, and this one is not on your graphic organizer, but we've done it with your airbag lab, and we've talked about it a few times. And if you need a review, I do have a video up about molarity on YouTube. But we now need to get from moles of acetic acid. Well, you would think that we would get back into grams, but acetic acid is in a solution, so we don't want to use the solution. I'm sorry, we don't want to use grams. We want to use that solution, so we need to know how many milliliters of acetic acid there are that we will need in order to make this many grams of sodium acetate. So that's what I'm going to put here is milliliters of B. Okay, so we know what we're starting with. We know what we need to find. We know what we've been given. And now we have a pathway. We have an idea of how we're going to solve this problem. So I'm going to rewrite that down here and say, all right, I have 1.7 grams of sodium acetate. And now I need to use my dimensional analysis in order to get out of grams of sodium acetate and into moles of sodium acetate. So what I'm going to do is put grams of sodium acetate on bottom. And the reason for that is that one of the beauties of dimensional analysis is that it helps you cancel out any labels. All right, so I'll continue my line there. And then what goes on top is 1 mole of sodium acetate. Sorry, my tablet is not writing very nicely. All right, so I have 1.7 grams of sodium acetate, and I have 1 mole of sodium acetate over a certain number of grams of sodium acetate. So what we need to do is we need to figure out how many grams there are per mole. And so we go back to the second month of school here, and figure out how do we determine the molar mass of sodium acetate. So we're going to take sodium, which has a mass of 22.990, and we're going to add that to 2 carbons, so that's 12.011, and I'm going to take that times 2, and this is all in parentheses so that I don't get my stuff mixed up. I have 3 hydrogens, which have a mass of 1.008, and I'm going to take that times 3 since I have 3 of them. And the last one I have is oxygen, so that would be 15.999, and I have 2 of those. And what I come up with is a mass of 82.03. Okay, so I know that's not the prettiest, but hopefully you can read that. So I have 82.03 grams of sodium acetate on bottom there. And so now I'm going to go back and look at what my plan was. And so I'm in moles of sodium acetate, and I want to get into moles of acetic acid. So I'm going to continue my dimensional analysis, and I'm going to put moles of moles of sodium acetate on bottom. And I want to put the moles that I want to get to on top. So in this case, the moles that I want to convert into is the acetic acid. So I'm going to write the formula for acetic acid up here. So the next step is to try to determine, well, what number goes with these moles? Well, the number that goes with it, we have to go back to our balanced equation and determine what is our mole ratio. That's what makes this stoichiometry. We're converting from one type of substance into another type of substance. So going back up to our mole ratio, well, we have no coefficient in front of the acetic acid. We have no coefficient in front of the sodium acetate. So what that's telling us is that it's a 1-to-1 ratio. 1 mole of acetic acid for every 1 mole of sodium acetate. So we are right here. We've converted in, if we were to solve right now, we didn't continue on with our dimensional analysis, our answer would be in moles of acetic acid. Now, moles of acetic acid is hard to measure, so that's not what we want to have it in. We want to get it into milliliters of acetic acid. So we are going to use one more step here, and I'm going to have moles of acetic acid. And because I am running out of room, I'm going to abbreviate acetic acid as AA. Okay, and on top, I'm going to have liters of acetic acid, or in this case, I'm going to skip a step because the conversion between liters and milliliters is really easy. Normally, molarity is measured in moles per liter, but I can also say that molarity is measured in moles per 1,000 milliliters because 1,000 milliliters is the same as 1 liter. And I'm going to put AA here again for acetic acid. Make sure you're using your labels. Remember, if I don't read labels, I assume it's cats per donut. And so now I need to find the number that goes in here. Now I don't have it written on the page here, but when we were working with our airbag lab, we were working with a 0.83 molar solution. So that is what I will use here. Now on your final, you've been assigned a different concentration of your solution. So instead of a 0.83 molar solution, you may have a 0.4 molar solution, or a 0.2 molar solution, or a 0.6 molar solution. You're going to have different concentrations, and so that will affect which reaction you're going to be working with, or what numbers are going to go in here. But now, if I take a look back, my labels all match. So I have grams of sodium acetate, so I'm going to cancel that out. So I have it on top, I have it on bottom. I have moles of sodium acetate on top and on bottom. So I'm going to cancel that out as well. And then I have moles of acetic acid, which I'm going to cancel out. So that leaves me with milliliters of acetic acid. So if I take a look at that, that matches what I wanted to find. And so now I can just solve. So what I'm going to do is I'm going to plug this into my handy dandy calculator and take 1.7, and then I could multiply across the top, take 1.7 times 1 times 1 times 1,000, keep that 1,700 there, and then multiply by 82.03 times 1 times 0.83. But what I'm going to do is just start with 1.7. I'm going to divide by 82.03, which is right down here. So I went from 1.7 to 82.03 because that's on bottom. I'm going to divide. Okay, to that times 1. Now I'm not actually going to type that in my calculator because multiplying by 1 doesn't do anything for me. I'm going to divide by 1. Again, I'm not actually going to do that because it doesn't change anything mathematically. Multiply by 1, Again, not going to do anything, but we don't take out this step because it shows us converting between the moles of sodium acetate and the moles of acetic acid. And then I'm also going to divide by 0.83 because of my moles of acetic acid, and multiply by 1,000. And so what I get is 24.96, I'm sorry, 97 milliliters of acetic acid. And I'm just going to keep it abbreviated as AA for acetic acid. Okay, so I have 24.97. Again, I apologize, that's kind of ugly, but hopefully we can still read that. So 24.97 milliliters of acetic acid. Now, actually, I can only use two significant figures, so I'm going to round this. The reason that I can only use let me back up for a second. The only reason I can use two significant figures is I have two significant figures here. I have 4 in this case, and then down here I have two significant figures. So that means I am limited to two significant figures. So I'm actually going to end up rounding this to 25 milliliters of acetic acid. But now I know how much acetic acid I am going to need. Now I could also do the same thing with baking soda, which you did do, except instead we went from grams to grams, which is a little bit easier. Now, for your final, you won't be going grams to grams, but you will be going from grams to molarity. Okay, so that's what I'm going to have you do. You'll follow the same steps, but you're going to have to insert the information that you would need for your particular final in order to do that. Please keep in mind that you can still ask me questions. I'm not hanging you out to dry. You can still ask me questions, but I'm hoping that this tutorial will help you kind of set up some of your equations. So thank you and good luck. I'll have one more video talking about theoretical yield in order for you to finish out your calculations. All right, thank you.